Hi everyone.
Today we will discuss pneumatic and vacuum braking system, and also what is the introduction of electrical system in automobile engineering. First of all, we will see what is pneumatic brakes and what is vacuum brakes, and after that we will see what is the introduction of electrical system in automobile engineering. What are the different electrical instruments and what are the different electrical setup we are used in the any types of automobile vehicles, we can see in this class. First of all, we can see what is pneumatic brakes. So what is the introduction of brake? You know about this brake. A brake is a device by means which frictional resistance is applied to a moving machine member in order to retard or stop the motion of a machine. We can stop the motion. We are applying some external force. We are applying some external force on that device. We can reduce the speed or we can stop the uh, object. That means we can stop the object or we can stop the vehicle. We are applying some external forces on it. Okay, so a brake is a device by means which a frictional resistance is applied. That frictional resistance means we are applying some external forces or external pressures. We are applying some external force or external pressures applying on that particular object or particular vehicle. A moving machine member, suppose I'm applying brakes on a vehicle, so the vehicle is moving, uh, the vehicle is moving, the running on your road. uh, it is a moving mission member, I am applying some external forces on it. That means I am applying brake in order to retard or stop the motion of a machine. That means whenever we apply the pressure on the brake, uh, the speed of the vehicle should be reduced, or else the vehicle should be stopped immediately whenever we apply the brake. Okay, so that is the main purpose of brake in the automobile vehicles. A brake is a mechanical device which inhibits motion, slowing or stopping a moving object or preventing its motion. A brake is a mechanical device. That means we are connected this brake by using different linkages or different connections or different vacuum braking systems or pneumatic. We are all are connected mechanically. So that's why it is called a brake is a mechanical device. It inhibits the motion conversion. Just I am applying the force on that brake pedal. It is vertically or any type of angular force are applying on that brake. So that is the conversion. That is the motion conversion, slowing or stopping a moving object or preventing its motion. Most commonly, brakes use friction between two surfaces pressed together to convert the kinetic energy of the moving object into heat to slow down the motion of the vehicle. So finally, in this any type of automobile vehicle, the kinetic energy is converted into heat energy. Okay, and pneumatic brake system and pneumatic brake system. You can see what is pneumatic brake system and what is the constructional details of the pneumatic brake system and what is the operation of pneumatic brake system. You can see a brake which uses air as working fluid is a pneumatic brake. So what is the main thing? It is air is acting as a main operating device in this pneumatic brake system. A brake which uses air as working fluid. So what is the fluid in this pneumatic brake system? Air. The system actuated to apply this phenomenon is known as pneumatic brake system. The system actuated to apply this phenomenon is known as brake system. And pneumatic brake or a compressed air brake system is a type of friction brake for vehicles in which compressed air pressing on a piston is used to apply the pressure to the brake pad needed to stop the vehicle. In already we have seen mechanical braking system. In those different mechanical braking system or a hydraulic braking system, in that hydraulic braking system we are using fluid on the hydraulic braking system. In that pneumatic braking system we are using air. So air acts as the uh, working fluid in this pneumatic braking system. So what is the main difference between these pneumatic and hydraulic braking system? It is in that hydraulic braking system we are using uh, fluid. That means brake fluids we are using. Those are different types of brake fluids we are using in that hydraulic braking system. In this pneumatic brake system we are using air. Okay, we are used compressed air in this pneumatic brake system. That is the main difference between hydraulic brake system and pneumatic brake system. It has a type of friction brake for vehicles in which compressed air pressing on a piston is used to apply the pressure to the brake pad needed to stop the vehicle. You can see JNTUK Westinghouse first developed pneumatic brakes for use in railway services. So the railway services, the pneumatic brake system are mostly used. It is developed in JNTUK Westinghouse first developed pneumatic brakes. He patented a safer air brake on March 5th, 1872. So one patent is raised in patent he gets in March 5th and 1872. Westinghouse made numerous alternatives to improve his air pressed brake invention, which led to various forms of the automatic brake used in the modern vehicles. For more safer and advanced braking system in the earliest of 20th century, after its advantages were proven in railway uses, it was adopted by manufacture of bus, trucks, and heavy road vehicles. So it was adopted by manufacture of buses or trucks or heavy road vehicles. We are using advanced pneumatic braking systems on different vehicles. What are the components of pneumatic braking system? What are the components of pneumatic braking system? You can see the components of the pneumatic braking system: air compressor, air compressor governor, air dryer, air storage tanks, and the brake pedal, direct collector, brake pipe, auxiliary reservoir, brake cylinder, brake block, triple valve. These are all components of the pneumatic braking system. You can see that order of the components of the pneumatic braking system. Air compressor. In that air compressor is connected to the air compressor governor, and it is connected to the air dryer. And air dryer is connected to the air storage tanks. The air storage tanks is connected to the brake pedal and the direct collector, brake pipe, and auxiliary reservoir, brake cylinder, brake block, triple valve. These are all different components of the pneumatic braking system. And you can see what is the arrangement of the pneumatic braking system. There is a compressor and the vane reservoir, driver's brake valve. The driver's brake valve means the driver's brake pedal. The driver's brake pedal. So in this driver's brake pedal is connected to the triple valve and the auxiliary reservoir. This triple valve is connected to the brake cylinder. Okay, this brake cylinder is connected to the brake block. This brake block is connected to the wheel of the automobile vehicle wheel. Okay, so these are the components of the pneumatic braking system. You can see what is in detail of these components: air compressor governor, and air dryer, and air storage. So the air compressor, it means the air compressor pump air into the air storage tanks, reservoirs. The air compressor is connected to the engine through gears or a V belt. This air compressor tanks is connected to the engine with the help of belt drives or gear drives. Okay, and the air compressor governor, the governor controls to the air compressor which pump air into the air storage tanks. And air dryer, an air dryer is used to make the moisture out of the air so that the water condensation will not build up in the air storage tanks. The brakes to fail, such as when the water freezes in the winter. Next, air storage. Air storage tanks are used to hold compressed air. The tanks will hold enough air to allow the brakes to be used several times, even if the compressor stops working. These are the explanation of the components, and you can see the brake pedal, direct collector, and brake cylinder, and the triple valve. So the brake pedal are applied by pushing down the brake pedal tool valve. The harder you push down on the pedal, the more air pressure is applied from the storage tank into the brake chambers. It is placed in the brake pipeline at a point from where a branch is taken off to the triple valve. So the brake cylinder is provided for actuating the brake rigging for the application and releasing the brakes. These are the working of the components in the pneumatic braking system, and you can see the overall working of the pneumatic brake system. The brake system that is passed upon the design air patent Georg Westinghouse in March 15, 1872. So the Westinghouse Air Brake Company was subsequently organized to manufacture and sell Westinghouse invention, which has been universally adopted. You can see what is the working. Compressed air from compressor passes through the valve and maintains its pressure. This air stored in the reservoir, and from the reservoir it goes to the brake chambers through many brake valves. In the brake chamber, this pneumatic force is converted into mechanical force, and then it is converted into the rotational torque of the slack adjuster, which is connected to the S-cam. This torque applies air brakes, which is used to slow down the motion of the vehicle. You can see the braking is done in three stages: charging stage, application stage, and a release stage. You can see the charging stage. During this stage, brake pipe is charged to 5 kg per centimeter square pressure, which is 10 charges control reservoirs and auxiliary reservoir to 5 kg centimeter square pressure via distributor valve. At this stage, brake cylinder gets vented to atmosphere through the passage in distributor valve, and there is no application of brake in the stage. So in this charging stage, the brake pipe is charged at the some amount of pressure, that is 5 kg per centimeter square pressure. The brake pipe is charged, which is in touch with the control reservoir and auxiliary reservoir to the 5 kg per centimeter square pressure via distributor valve. So that is the main purpose of the charging stage. And you can see the application stage. For application of brakes, the pressure in brake pipe has to be dropped. This is done by venting air from driver's brake valve. Reduction in brake pipe pressure positions the distributor valve in such a way that the control reservoir gets disconnected from brake pipe, and auxiliary reservoir gets connected to brake cylinder. The magnitude of the braking force is proportional to the reduction in braking pipe pressure, which is done by the application of force in brake pedal. You can see the overall working of the application stage. Whenever the brake pedal is pressed, automatically there is a cylinder. In that cylinder, there is a piston. So in that cylinder, there is a air is available. When the piston is moving, automatically the air is compressed, and the air is passed through the air passed pipelines. Brake pipe air. You can see the brake pipe air lines. The air is passing through that pipelines, and the air is move on to the brake cylinder. The brake cylinder has a spring and piston, so that piston is compresses the spring, and the air is passed through the brake block. The brake block is attached to the wheel to stop the vehicle. So it is the overall working of the pneumatic uh, braking system. So that release stage, whenever we release the pedal, automatically the spring is expanded to release the uh, air, and it will come to the normal stage of the brake pedal. Okay, it is the release stage. The brake pedal is disengaged with the vehicle wheel. The vehicle is disengaged with the vehicle wheel. Okay. So it is the overall about the pneumatic air compressor. What are the advantages? You can see air is available everywhere in atmosphere, so the brake system can never run out of its operating fuel. So the main advantage is air is available in everywhere. Air does not corrode the metals, so the life of pneumatic brake is more. So air is does not corrode the metals, so the life of the pneumatic brakes are more. Airline couplings are easier to attach and detach the hydraulic lines. There is no danger of lettering air into a pneumatic circuit. And you can see pneumatic brakes has a got emergency brake which gets activated when the service brake fails, so it is very safe. These are the different advantages, and you can see the limitations. If the brakes are applied before recharging has been completed, a larger brake pipe reduction will be required in order to achieve the desired amount of braking effort. Okay, if the brake pipe pressure is too low due to an excessive number of brake applications, an emergency application will not produce a large enough volume of airflow to trip the triple valves, leaving the engineer with no means to stop the vehicle. So these are the limitations and application. You can see the pneumatic brakes is mainly used in large vehicles such as trucks, buses, trailers and semi trailers, in addition to their use in railway trains also. So these are the applications of the pneumatic brakes. Okay, so it is overall about the working and operation and advantages, disadvantages and applications of the pneumatic braking system. And next you can see what is vacuum brakes. And next you can see what is vacuum brake systems. In this vacuum brake system, you can see what is the introduction of vacuum braking system and what is the history and what are the different components of vacuum braking system and what is the working and operation of the vacuum brake system. What are its advantages, limitations and applications of the vacuum braking system. First of all, you can see what is the introduction of a vacuum braking system. That vacuum braking system, a moving train contains energy known as a kinetic energy which needs to be removed from the train in order to cause it to stop. For example, what he told is a moving train contains energy. A moving train has some amount of energy. So it is known as kinetic energy which needs to be removed from the train in order to cause it to stop. The simplest way of doing this is to convert the energy into heat. So the kinetic energy is converted into heat energy in any type of brake you are applying in the automobile vehicles. Okay, so the simplest way of doing this is converted into the kinetic energy is converted into heat energy. You can see the conversion is usually done by applying a contact material to the rotating wheels or to discs attached to the axles. The materials create friction and converts the kinetic energy into heat. The wheels slow down and eventually the train stops. The conversion is usually done by applying a contact material to the rotating wheels. So if the train wheels are rotating, so some other external material, some other external contact material is contact with the uh, rotating train wheel, automatically the heat is generated. That is the discs attached to the axles. The discs are attached to the axles. When the kinetic energy is changed into heat energy, the material creates friction and converts the kinetic energy into heat. Whenever that pads or that shoes are attached with the running wheels, automatically the kinetic energy is converted into heat energy. Then the wheels slow down and eventually the train should be stopped. So the material used for braking is normally in the form of a block or pad. So what is the principle of vacuum brakes? The vacuum brake system is controlled through a brake pipe connecting a brake valve in the driver's cab with the braking equipment on every vehicle. So the vacuum braking system controlled through a brake pipe. There is a brake pipe. In that brake pipe, the vacuum is used to flow that brake pipe, and we can stop or reduce the speed of the vehicles by using this vacuum system. In that brake pipe is connected to a brake valve in the driver's cab with a braking equipment on every vehicle. Okay, in that vacuum brakes on any type of vehicle, there is a brake pipe. So that brake pipes are connected to the brake valves. It is in the driver's cab with the braking equipment on every vehicle. The ejector using steam on a steam locomotive or an exhauster using electric power on the other types of trains removes atmospheric pressure from the brake pipe to create the vacuum. With a full vacuum, the brake is released. With no vacuum, at normal atmospheric pressure in the brake pipe, the brake is fully applied. So there is a ejector using to steam on a steam locomotives. There is a steam locomotives. The steam is developed on an exhauster using electric power on the other types of train removes atmospheric pressure from the brake pipe to create the vacuum. With a full vacuum, the brake is released. With no vacuum at normal atmospheric pressure in the brake pipe, the brake is fully applied in the uh, locomotives. You can see the history of vacuum brakes. Vacuum brake was introduced around the early 1870s. Just a second. So you can see the block diagram of the vacuum braking system. In that vacuum braking system, you can see what are the different components. There is a exhauster and a driver's brake valve, and it is connected to the dummy coupling, and it has a brake pipe on second vehicle. It is a coupled houses between vehicles, and it is connected with the brake cylinder. In that brake cylinder has a vacuum reservoir. So the vacuum is placed in that vacuum reservoir, and there is a ball valve. That brake cylinder is connected to the brake rigging. This brake rigging is connected to the brake block. The brake block is contact with the vehicle wheel. Okay, so you can see there is a exhauster. Whenever the driver's pedal, whenever the pressure is applied on the driver's pedal, automatically it is uh, the vacuum is travel through this brake pipes, the vacuum brake pipes, and you can see there is a vacuum cylinder and brake cylinder. The vacuum is passed through the vacuum brake pipes. Okay, so there is a vacuum reservoir, and the vacuum reservoir, the vacuum is passed through the brake pipes. Whenever the pedal is pressed, automatically there is a compression pressure is increases to compress the vacuum, and it is move on to the ball valve to the brake cylinder, and also it is moving brake rigging. The brake rigging is also moving, and the brake block has contact with the vehicle's wheel. Whenever we release the pressure on the brake pedal, automatically it is disengaged with the vehicle's wheel. Okay, it is the overall working of the vacuum braking system. What are the components? You can see driver's brake valve. It means which the driver controls the brake. The release position connects the exhauster to the brake pipe and switches the exhauster to full speed, and it raises the vacuum in the brake pipe as quickly as possible to get released in the running position, and exhauster keeps running but it's slow speed. This ensures the vacuum maintained against a smallest or losses in the brake pipe, its connections and hoses. You can see the exhauster. It is usually controlled from the driver's brake valve. Uh, what is the main purpose of this exhauster? It is to control the driver's brake valve and being switched it in a full speed to at a brake release or at a slow speed to maintain the vacuum. So the brake block, uh, it is a friction material which is pressed against the surface of the wheel led by the upward movement of the brake cylinder piston. These are the different components of the vacuum braking system and working of the vacuum braking system. you can see the brake valve is open in condition. In a vacuum braking system, depressing the brake pedal opens a valve between the power cylinder which contains a piston. So in that brake valve, it contains piston also, and the intake manifold to which the power cylinder is connected. When you apply the brakes, air is exhausted from the cylinder head of the piston. At the same time, atmospheric pressure acts on the rear side of the piston to exert a powerful pull on the rod attached to the piston. It is the working, and you can see brake valve is closed. When the brake valve is closed, the chamber ahead of the piston is shut off from the intake manifold and is open to the atmosphere. The pressure is then same on both sides of the piston, therefore no pull is exerted upon the pull rod. So the brake valve is closed. There is uh, no pullings is exerted on the pull rod. The brakes are released and the piston return to its original position in the power cylinder by the brake shoe return spring. So what is the small theory of this brake valve is open and closed? Whenever the brake pedal is pressed, automatically the brake valve is open. Whenever the brake pedal is released, automatically the brake valve is closed and piston gets um, a normal position to get the piston. So it is the main purpose of the brake valve open and closed. Okay, so that is the brake released. The vacuum is passed through the brake lines. It is connected to the brake rigging. The piston is connected to the brake rigging. It means whenever the brake pedal is compressed, automatically the vacuum is compressed. The uh, vacuum is passed to the vacuum reservoir through brake cylinder, and the piston is moving. That piston here we are connecting a brake rigging. The brake rigging is pushes the brake shoes. It is contact with the wheels. Whenever we release the brake pedal, automatically the piston gets normal position and it is disengaged with the automobile vehicle wheels. Okay, it is overall working of the vacuum braking system. And you can see what is the next one, next topic, what is the introduction of electrical system in the automobile vehicle wheels. Automobile vehicle wheels. You can see the introduction of the automobile vehicle wheels electrical system. Automobile electrical system includes starting system, charging system, ignition system, and lighting system, and some other accessories. The accessories include cigarette lighter on the mobile charging system. Those are different electrical system in the automobile vehicle. Suppose one automobile car I am taking. So in that automobile vehicle's car, there is a lights, horn, and charging socket, and radio socket, and video. Some different cars video facility is also available, and FM radio. Okay. Um, and signal lights. These are all different electrical systems in the automobile vehicle wheels. So how we generate the electricity in that those different accessories to that automobile vehicle wheel. So the accessories include cigarette lighter, horn, and the mobile charging system also included. So what are the major components in the automobile vehicles? Automobile vehicles in the electrical systems, it is the ignition system. So the ignition system, it is a spark plugs for petrol engines, distributor, ignition coil, ignition switch, and a charging system, alternator, regulator, and starting system is battery. These are all electrically operated system. So how should we generate the spark in the uh, petrol engines or any other different automobile vehicles? It is we cannot kick the rod in the automobile vehicle wheels. Just we can apply a self on the automobile vehicle. That means a battery charging is available. The electricity is generated. That electricity is converted into a spark on the spark plug. Automatically, the piston is running. Okay, so whenever the spark is created on the spark plug, automatically the power is developed on the uh, piston and cylinder. Automatically the piston is running. Okay, and ignition coils and ignition systems. These are the different ignition systems and charging systems and the starting systems of the vehicle. What is ignition system? In spark ignition engines, a device is required to ignite the compressed air fuel mixture at the end of compression stroke. So, at the end of compression stroke, whenever the vehicle should be stopped, there is a compressed air fuel mixture is available. There is ignites with one spark is developed on the uh, spark plug or any compressed air fuel mixture on that. It is petrol engines or diesel engines. Once spark is developed on that piston and cylinder, automatically there is a power developed and the vehicle engines run smoothly. Okay, so it is the ignition system. It is a part of electrical system which carries the electrical current at required voltage to the spark plug, which generates a spark at current time. It consists of battery, switches, distributor, ignition coils, and spark plugs and the necessary wiring. These are all electrical systems in the vehicle. You can see what is the requirements of the electrical systems in the automobile vehicles. The ignition system should be capable of producing high voltage current as high as 25,000 volts. Highest amount of power is developed in the automobile vehicle engines. So that the spark plug can produce spark across its electrode gap. It should produce spark from sufficient duration so that mixture can be ignited at all operating speeds of automobile. Ignition system should function satisfactory of all engine speeds. Longer life of contact points and the spark plug. Spark must generate correct time at the end of compression stroke in every cycle of engine operation. The system must be easy to maintain, light in weight, and compact with the size. These are the requirements of the electrical systems in the automobile vehicle wheels. You can see what are the types of ignitions in the automobile vehicle system. There is a battery ignition system or coil ignition system, magneto ignition system, electronic ignition system. These are the different types of ignition systems we are used in the automobile vehicle wheels. It is the circuit analysis of the battery ignition system. You can see the battery, and the battery is connected to the ammeter, and ammeter is connected to ignition switch, and it is primary winding, contact breaker. There is a coil arrangement, and that contact breaker is connected to the secondary winding. It is attached to the distributor, contactor, and distributor under spark plugs. These are the components of the battery ignition system. What are its advantages? It is a low initial cost, uh, better spark at low speeds, and a better starting than magneto system. Reliable system, no problems due to adjustment of spark timings, simpler than magneto system. Okay, so these are the different connections of the battery ignition system, magneto ignition system, and electrical ignition systems. So why electronic ignition? It means the disadvantages of the mechanical ignition system is that it requires regular adjustment to compensate for wear and uh, opening of the contact breakers, which is responsible for spark timing. It is subjected to mechanical variations. In addition to the spark voltage is also dependent upon the contact effectiveness, and poor sparking may lower the. So the mainly it is a wear resistance. To decrease the wear resistance, we are providing the electronic ignition system on the automobile vehicles. So what is the ignition timing? Ignition timing is the correct instant of generating spark just before the completion of compression stroke. So there is a compression stroke. We can develop the ignition within time of spark at the adjustment of completion of compression stroke, and the correct ignition timing is necessary to maximize the power output of an engine. Okay, so these are the different sparks in the automobile vehicles. These topics we will discuss in next class.
So what is spark plug and what is hot and cold spark plugs and capacity discharge ignition and what is head lamp and horn circuit. These all are electrical systems in the automobile vehicles. In detail about these electrical analysis of the system, we can explain in next class. So thank you guys.